Okay, so in this video we'll talk about something I think everyone loves, which are rainbows, and we'll get the answer to our question number 2 out there. Question number 2 asks the question, how are rainbows formed? So we'll get the answer to that coming up. Turns out as we start then, just know then that rainbows are definitely a dispersion effect. So as beautiful and familiar as rainbows are, it is dispersion that describes where they come from. Let's take a look. Here's a rainbow here that we're talking about. I'm sure everyone has seen one before, and they're just really beautiful. I can't think of anyone who doesn't actually stop just for a moment of their busy day to look up when you see a rainbow. They're just sort of nice to see. So I think the things that you associate with rainbows are definitely rain. You don't see them on clear days, and of course rain implies something about water. Okay, so there's your first clue to dispersion right there, because water is not air, and so there might be some sort of refraction going on. There are definitely some trends in the rainbow here, in particular on the very top of the rainbow you'll see the reds, and on the bottom that's where you see the blues or violets. Here's a rainbow that I saw over my house one day. I was literally getting in the car to go to work to teach astronomy. You can see even I have my car door open right there. And I just happened to look up and I saw the most beautiful rainbow over there in the sky. And I just stopped everything I was doing. And this is just a panorama shot on my phone and everything. I scanned all around this way, just to capture that nice rainbow there. Look how nice that one is. Big semicircular arcs. Like, wow, that's great. But you can see there's some rain out there. The ground is all wet. So again, it has something to do with the rain and water. Here's a close-up of it right there. See that? This is this awful street lamp that prevents me from seeing the Big Dipper when I look outside at night, because my north is that way. But anyway, beautiful rainbow there. So let me give you a little insight then about how these rainbows occur then and what needs to happen in order to see a rainbow. So it's going to work like this. Ooh, a little too thick there. And these things are just beautiful. Okay, so it's going to work like this. If you're going to see a rainbow, a couple things have to happen. You're going to be down here on the ground like this. And let's say you're standing right about here. Okay, and the first thing that has to happen is the sun has to be behind you. The sun must be behind you. You never see a rainbow by looking at the sun or to the side, anything like that. It has to be behind you. And that's sort of what happened on days like this here, is you can see that as you might take the shot. I'm definitely not looking into the sun, for example, here. Okay. In fact, if you look very carefully at the shadows here, for example, so here's this tree here that I have in my front yard. There's this tree here, and you can see the shadow of the tree down here on the sidewalk. So what that's telling you is that if you can see this red cursor here, the sun is definitely over back in this direction here. The sun is like way back here. So this did meet the condition of the sun being behind me, because the light rays from the sun would be coming in from this direction, casting that shadow, and then going on to this portion of the sky, causing the rainbow to happen. So we'll get to there. So there's the sun behind me. So that's what I always look for when I start looking for rainbows, is I say, well, there's the sun right behind me and the rainbow's right in front of me. Okay, so the next thing that it must be happening for a rainbow to occur is there's got to be some water in the sky. So it must have just rained or still raining or something. And so what you'll get is, let's say there's going to be a bunch of drops in the sky here. And one of the things about rainbows is the drops have to be large drops. They must be large for reasons why I'll tell you in a minute. And so large drops, of course, usually implies that they're too heavy sort of to swirl around up there, so they're probably falling. In other words, it's probably raining. Okay, so if you just take then, I'll just sort of leave that. There's the drops there, but I'd like to look at just one drop in particular. So suppose we have a big drop like this. So this is greatly magnified, I know, but I'm just trying to show you what happens here. Okay, here's what happens. You can have some sunlight coming in that's going to go like this. Here comes the sunlight, and it's going to hit literally. The discussion starts at where some sunlight hits sort of the air-water boundary for a raindrop. So the light is literally penetrating into a raindrop. That's the beginning of how a rainbow forms. And then what happens, of course, here is you have this air-water interface, and you can go all crazy with your optics and draw your normal and all that sort of thing, but the light is going to bend here. There's definitely an interface where the light's going to bend. And now you know that dispersion is something that you sort of can't escape. Dispersion just happens. And so what has to happen now is if we didn't know about dispersion, we would just draw a white beam going into the raindrop like this, and we'd sort of maybe still question, well, where is the rainbow? But we know about dispersion now. That's something that we just discussed, and you can't escape dispersion. It's just as part of nature. Dispersion is alive and well in the raindrop. So what that means here is, of course, dispersion, as we discussed with the definition here, is the separation of light due to its color. That's what dispersion is. So indeed, we spent a lot of time talking about the prism in dispersion, but water can do the same thing. Water's on the chart of index refraction, has the number, it's higher for N, lower for red, all that sort of thing. So you will get dispersion in the drop itself, which I'll show you in the next video.